trust me. So what we're doing here today is just some real basic stuff. We've used vertical line test. We know how to find zeros. We know how to look at intervals. That's kind of the new-ish, because we're going to talk about how you label things on intervals. And then we're going to look at average rate of change, which is nothing more than slope, really. And then even in odd functions. So like I said, vertical line test, that's old stuff. You've done that. That's easy. Finding zeros, that's old stuff. You've done that. That's easy. Zeros are when you factored. Things like that, where what's across the x-axis. Increase or decrease, very, very easy to work with. Okay? You probably did that. And then, like I said, rate of change is slope, but it just looks weird how they write it out. So, this book, as it gets to more of a technically written text, they start to talk about domain and range on graphs a little bit differently. They start to write them out as, hi, thank you, buddy, you're the best. Thank you. This was from my house.
Oh, so that was just like 6, 7 now?
Yeah. Okay. Thanks, though. Yep. Good to see you. Good to see you, too.
We should do this again sometime.
We should. My best friend in the whole wide world. What does this mean?
X, Y.
F and f of x, and f of x is a synonym for y. If it's a function, very good. If it's a function, it just means it's function of x. So what they'll do is they'll list their ordered pairs as x and f of x, which means the same thing as your ordered pairs x and y. All right. The other thing that they talk about with domain and range, do you remember what domain was? Possible x values. Range is possible y values. These are your x values and your y values. What's going to be a little bit new is this thing called interval notation. An interval notation. You've probably seen it, you just didn't know you were using it. So if we're looking at something called interval notation, they're saying they're looking for like what's called a snapshot, a little bit in time. If I'm looking at this, this is just one simple part of a graph of a function that starts at -1, 1, oscillates through, and it has an open dot then at 5, 2. So what I'm looking at as my domain, that's my possible x values. My range is my possible y values. So the low spot for your range was at -3. The high spot is +3. So on an interval, here's our domain and our range. I'm going to do the range first. The lowest value of your range is what? And what's the highest value? 3. Now, looking at that graph, are they open or closed dots on -3 and +3? They're closed dots. Does that mean it's including them then? Yeah. Whereas, see how this one's an open dot there? So there's little differences here. So if I'm looking at the range, my range is going from -3 to +3. And I'm putting brackets. That's interval notation. That bracket like that is going to show interval. Like I said, I think you probably have seen that before. Excuse me. What's that? Oh, yeah, I didn't even think of that, to be honest with you. Now, look at your domain. Your domain is your x values. What's the smallest value of x according to that graph?
1.
-1. What's the largest value?
5.
X value.
5.
5. I'm looking at, because my domain goes this way, and this is where it gets different. Because it's got an open spot we put a parenthesis on it.
Oh,
Have you seen that before?
no.
Really? I'm surprised. I thought you guys might have seen that before. All we're looking at here is what's called interval notation. Interval notation is showing whether or not it's an open or a closed dot at a specific point. That's it. A hard bracket means it's including. A soft bracket means it's not. That's it.
So, why is the
Because it just so happened in that picture it had a hard dot on it. That's all. It doesn't have to be. We could have had a graph that was completely set up differently, where this could have been open. You know, it just every one of them.
What's the difference between open
It does not include. Maybe it's what happens is there might be an aspect of that. Okay, something like that. Yes, sir.
Can you have like multiple open?
Yeah, absolutely, absolutely. Real easy one to remember from trig from last year. What oscillated to an undefined function at 90 at pi over 2 and 3 pi over 2? Tangent. Tangent had an open interval at pi over 2, 3 pi over 2 because it was what do you call it? It was an asymptote. So it never included it. You've done that, you just never wrote it in terms of brackets and parentheses before. That's all. It's just an excluded value, if you will, when they're putting those on there. That's it. Okay? So don't get worked up on it. It's really quite simple. You know how to do this. I'm not even going to bother writing any of this out. Vertical line tests, we talked about it last week also. If the vertical line touches two places, is it a function?
No.
One of the easiest things to do. Real fast though, will this one be a function?
No.
Who says no? Who says yes? Who has no flipping clue? All right. It's a function. Anywhere you touch, does that vertical line touch more than two spots at the same time?
No.
No, so it's a function. Even though there's a break in the interval, it's okay.
What do you mean if you don't touch two spots at the same time?
When I take my vertical line
Oh.
and I'm moving my vertical line through here, my vertical line is only touching one spot all the way through, then it's a function. Whereas on this one here, it was touching two spots, which means it's not a function. That's all it is. Even though there was a break in the domain, it's still a function. That's all. Because it was never touching more than two spots at the same time. It works out just the same. Zeros. This is where it goes back into remembering how to do some factoring, solving, and things like that. Now I want to spend a little bit more time on this because over the course of the years, I know that you guys have a tendency to forget to do this stuff correctly. So what we're going to find are the zeros of the function. And in finding zeros of a function, all you're doing is taking that equation, set it equal to 0, and solve. Each and every time. What's going to throw you for the loop is the idea that you have to remember how to factor in some cases. You might have to remember how to solve square roots. All those little bits and pieces. Sir?
That's the question. In order to get rid of square root, you have to parentheses and square, right?
Correct.
All right.
No, that's all right. So here, 0 equals 3x squared plus x minus 10. That's setting you up with factor. I always factor these by what's called split middle term, or factor by grouping. What I'm doing here is I'm taking the first term times the last. What's 3 times 10?
30.
What times what is negative 30, but I add it together to get positive 1. Which one's positive, which one's negative? Very good. What she said there is, what I'm doing is I'm taking what times what is negative 30 to get 1 in the middle. Negative 5, positive 6. Okay? It's just factor by grouping. I split this middle term out. Whenever I do factoring, it's usually a little bit longer than some of the other ways people have shown. But this method of splitting out that middle term will always work. Might take a minute, but it always works. I rewrite it and I get 3x squared minus 5x plus 6x minus 10. And then I just pull out GCFs. I do that twice.
Would it be easier to do the 3 and 6? Yeah.
Does it matter? It doesn't. And there's a reason why I put that negative first. I'm less likely to screw something up by factoring out that negative in that third term. You can do it. By all means. It doesn't matter which way you do it. Because negative 5 and positive 6, you add them together, is still positive 1. Negative 5 plus 6 is positive 1. 6 plus negative 5 is also positive 1. Commutative property of addition doesn't matter. Doesn't matter at all. What's my GCF here? X. What's the GCF of 6x and a 10? 2. And lo and behold, you're left with the exact same thing in the parentheses, which is good because that's what you want to happen. By putting that negative first, if you've got them both, I don't have to worry about factoring out a negative the second time around. That's the only reason why I do it that way. Are both those things in parentheses the same?
Yeah.
So you write it down. And you're left with x plus 2. Remember, that was all set equal to 0, so what are your two zeros of the function in this case? Negative 2 and 5/3. You're done. Factoring. Okay? The little short, quick factoring ones like that. Did it change when you have to find a 0 for, move this back up, put this on another sheet. Sorry about that screen pop there, but whatever. G of x is the square root of, G of x is square root of 10 minus x squared. Yeah. I started out by writing it as, 0 equals. Excuse me. And like you said earlier, how do you undo square rooting? What's 0 squared? That was easy. Now what do you do?
You factor them out, factor the x squared minus 10 out, so wouldn't it be x minus 5 parentheses x plus 5?
Well, then it would be x squared minus, be x squared minus 25.
Wait, but why would it not be x? Aren't you gonna get like your square root equal?
Okay, I took the square root of jump squared. You get just jump.
Okay.
Remember, the idea that's going on in here is that you have the square root of x is x to the 1/2 power. You guys remember that from last year? And if you do this and you square it, power to power, multiply. So 2 times 1/2 was 1. That's why this works. And it doesn't matter that you had all this other stuff underneath here because it's all of this raised to the 1/2 power then squared. So it cancels itself out. The exponents go away. A square root is just a fancy exponent, is really all it is. So then we wind up with x squared is 10, or plus or minus. This is the case I have to go plus minus because I take the square root over the equal sign. Yeah, you can't simplify square root. If it's square root of 12, you could. Very good. Yep. Yep. Okay. There is a way, if you guys remember from last year, do you remember how to find the square root in one of these types of calculators?
I had a question.
What do you got?
Yeah, but if 10 goes to the other side of 0, wouldn't that be negative 10?
I added the x squared to the left. I did this. I kept the 10 in the same spot.
All right, never mind.
That's all right. In here, if you go to your menu, no, hit the on button, the home screen, and then go down where it says graph. It's part B. Highlight where it says graph. Hit enter. All sorts of stuff going on in here.
How do you like, I hate
I don't know why this one's all sorts of crazy. I need to,
How do you clear everything? You just have to
Press
yeah.
control menu.
One, four.
Make clear history.
alright, if you hit, menu, yeah. So let's see here, where do I put in my y equals? Tab? Thank you. To type in your y equals, once you're on the graph screen, you hit tab. Now, what I can do to figure out a square root is that, let's say it's 12. We all know the square root of 12 is 2 root 3. If I type in 12 divided by x squared, and I hit enter,
Wait, where?
and then if we go to menu, we want to go to our
Table,
table, which is
seven.
hit view, menu 2, 5, there it is.
Wait, what'd you go? What'd you go to table? It's seven.
I got 2, 5 when I did that.
How did you do that?
If you hit, and I apologize guys, my computer, it's still not allowing me to download the correct software on this to make it work. But on yours, you go into where it says menu 2, 5, and you'll be able to see a table up there.
It's also seven.
Or is it just 7?
Yeah.
But what happens is once you look at that table, you're looking in the table. You have your x's and your y's. It should say 1. If it's 1, it'll be 12. 2, and I think it says 3, and 3, and then there's some decimal numbers. It should say that in the table. What happens is what you're looking for is the largest values before you get to all decimals in the y column. The number in front would be the number outside the radical. The number inside is the number underneath the radical. So the square root of 12 becomes 2 root 3. Okay? That's how that would work. The other one, pull this one out. Once again, we go to solve for our zeros.
We just had both, sorry, both numerators on here.
If you set, bless you, if you set just the denominator equal to 0, you're just finding out where there's an undefined part of it. You're finding out the asymptote, if you will. Okay? By setting the whole function equal to 0, and then solve it. So what happens here is that you have fraction equal fractions, you're going to cross multiply. The denominator basically goes away. Because I'd multiply this side by t plus 5, and then I'd multiply this by t plus 5. So 2t minus 3 is 0. Just by moving that around real quick.
Oh, see, I tried to do that. I put the other side.
I just multiplied, cross multiplied, it got rid of the denominator. How do you do this? Multiply both sides by 2, right? Same thing. It's the same exact process. And then you just wind up with 3 over 2. Okay. I just cross multiplied. I solved the equation. I was finding the zeros. Where does it cross the x-axis? Whenever you set a function equal to 0, you're finding where it crosses the x-axis. You're finding the 0. Okay? That's all it meant. Set it equal to 0 and go. All right. That's all that meant. Like I said, most of this is, the 0 part's pretty straightforward. But I do want to spend a minute discussing with you guys what does it mean to be increasing and decreasing. I don't want you to, Devin just freaked out because she just saw all this stuff on the board here. And I was just about to say, I don't want you guys to get freaked out by all the words. Increasing and decreasing functions, it is ridiculously simple to do. How do you guys read a book? From left to right or right to left? From left to right. So if I'm looking at this graph right here,
You read it
going from left to right, notice how this graph is decreasing from left to right, then it stays constant going from left to right, and then all of a sudden it's increasing again. This is a whole lot of mamma jamma for just looking at a picture going from left to right. That's it. What's the graph doing as you're looking at it from left to right? If I start to look at it in terms of values, and this is what we're gonna spend time on. I'm gonna write it out in terms of intervals of where it is increasing and where it is decreasing. And I'm gonna use those open and closed brackets again. So if I'm looking at this, we know it's decreasing going from -2 to 0. I'm looking at my domain. Okay. It's decreasing between -2 and 0. Oops. It's constant. Look here, from 0 to 2, and then it's increase from 2 to 4. This is very, very simple. You will have the infinities thrown in there. Yes, sir?
What if the, on the increasing like the last dot, that was open, would you put like a
The soft? I was just kidding. Yeah. That was okay. No, that's fine. It's no big deal. You'll have your open and closed parentheses again. Like I said, these are very, very easy to work with. Okay? There's no trickiness with increasing and decreasing. It's just a matter of looking at the actual graph itself. The book, again, uses a whole lot of words, oops, just to talk about, this is all tricky. Just to talk about what's happening as x is going across. Is f of x increasing or decreasing? That's it. You're looking at your x to what the function is doing, which is the f of x. That's it. All right? That's all it is. So if I'm looking at one in the middle. How would I write this out from where it's increasing to where it's decreasing to where it's increasing or constant or anything like that? What's that? You're close. Think about it in terms of x. There's no bottom to this, correct? So does that mean this is constantly falling?
Yes.
If it's constantly falling, isn't it also moving to the left?
Yes.
If you're always moving to the left, then what are you approaching?
negative infinity?
Negative infinity, very good. So I know that from negative infinity to 1, oh, excuse me, negative 1, I'm increasing. Okay. Negative infinity would have an open bracket on it. The reason it has that open bracket is because infinity is constant.
Why would it be negative one?
Because I'm looking at my x values. Okay?
Wait, yeah, no, yeah. How does that make sense? That's in the x, y place.
This is just an interval. Your intervals are, you're looking at, your x value. You're looking at the domain. Well, what values of the domain is this increasing? but what values of the domain is it decreasing? Because the graph that you visually see is f of x. The concept that you're working with is moving from left to right, which is giving you that domain. Yes, ma'am.
So you use soft brackets because it's over circle.
No. What's happening here is that it's negative infinity. Are you ever going to get there? No. So there's no hard cap.
Okay.
Okay.
And so that's
Yeah. Yeah, so it's increasing from negative infinity to 1. Now, I believe in this one, since you've got that shift, where it shifts from increasing to decreasing. You were thinking H's and K's, weren't you? What they're going to look at is that they're not so much worried about the hard bracket as far as like your intervals, like domain piece that we looked at earlier. Just saying what's happening. Well, it increases from negative infinity to negative 1. It decreases, so this was an increase. Oops. It decreases, I'm just going to use a D, between negative 1 and positive 1. And then it increases again from positive 1 to positive infinity. You're looking at the domain values of x to where things are changing. That's it. The graph itself that you see, like I was telling a second ago, that is the f of x. It's just a little weird in how they word things through in this book. I know that every single one of you guys could look at this graph and say it's increasing from left to right, from the left to negative 1. It decreases from negative 1 to positive 1, and it increases again on the way back out. That's what you have to be able to do. If you can do that, you're fine. That's it. It's a lot wordier than it needs to be. Yes, ma'am. Good, anyone else? We talked a little bit about relative maximum. Remember local maximums and minimums last year?
Yeah.
When we did like the cubic functions, the 4-3 functions, we just kind of looked at it in our calculator. It's the same thing. What we're looking at this stuff here is, again, the book uses so many words to make your head spin that it just gets nasty. But it's written in terms of a technical language. Not necessarily. It depends on the interval that you're looking at. So depending upon where you're at in a function, it does not matter. Between one interval, there could be a localized maximum, a localized minimum. On a different interval, those could be different. All this is saying is that at some snapshot, I think we had a graph, we probably did one last year with a 4th degree where you came up, down, you did something like that. We might have graphed something like that, where there was no maximum or minimum because of all the changes of direction. But we would say that this was a localized maximum, a localized minimum, another localized maximum, depending upon which intervals you were looking at.
Oh, yeah.
That's all this means, guys. Your calculator has a button that says relative max, relative min. There's a trace function on your calculator that will find these values for you.
Oh, yeah.
Okay? Yours is a little different. Yours will actually hit you go to
Oh, yeah, I know, I did that.
yeah, the max min stuff. It's the same idea. And you have to set your boundaries on it. These calculators, you don't remember last year you had to set your boundaries for it to look for a relative maximum or a relative minimum?
Yes.
These will do it for you just by tracing it over. It's a matter of seriously just playing around on the calculator and pressing buttons and seeing what you can do. Okay? Yeah, quick.
Is it this?
Which one you got?
6 and 7, or is it different?
No, that's different. What you're going to do on this one in your graph, if it's sexy, it's calculate. Maximum minimum. Oh, let's see. So we want to do menu. Delete all. All right. So if you put in a regular boring f of x, let's see if we have an example here. If we put in negative, oh no, if we type in x cubed,
In your y value,
yeah. I'm trying to figure this out. Trying to type in the thing, it's not even letting me do this. This thing's annoying me. Anyway, there will be buttons that you can find to localize maximums and minimums. Okay. What we need to do is figure out more stuff on this calculator. Do me a favor, when you're doing your stuff today, go on the website, and I actually have a spot for you. On the pre-calc. I put on here, oops, where is it? One of the, which one was it? The how to use the T and I Inspire one. Just spend a minute. They'll walk you through a bunch of stuff. Or you can Google it.
Hey, you know you
Doesn't
made,
ignore you in everything.
on your link, on your page, Mr. Merkley,
Mm-hmm.
it says.
So there's time.
This is not to call, or this is to call, not to share.
Oh.
On the right.
But there's all these little fundamentals. Spend 10 minutes on these things. It'll show you all the little stuff on here, how to use the quick buttons on the calculator. It walks you through it. Once you get the hang of this thing, it is so much nicer than the 84. I do too, but I'm still messing around with this because obviously I'm still learning how to use it for myself. But it's going to be more powerful, it's going to do a lot more stuff for us. The trace functions, less buttons to press, things like that. So, spend a little time on that. Last little bit, before we run out of too much time, was average rate of change. This is kind of new. What we're looking at here is what's called average rate of change. And this is something that they do quite often when you get into calculus. Towards the end of the school year here, we're going to be dealing more and more with this average rate of change stuff with functions. What's going to happen is we're finding the slope between 2 points on some given function. And how do you find the slope? Rise or run, change in y, or change in x. So what we're looking at here is the change in y over the change in x. But remember, they're writing out their ordered pairs as x and f of x. So instead of saying change in y, I'm going to say change in f of x. That's the only thing that's different here, guys.
which is the same thing as y, right?
Yes, sir. They label out their stuff in terms of f of x as opposed to just y. Because they're talking about functions. Okay? They're talking about more specific. So what we're going to look at here is just real basic f of x.
Wait, question. Are they, it's like, is it going to be f of x for everything the whole year or just this chapter?
It mixes
Okay.
a little bit. It mixes. I mean, for the most part, if you remember that you have f of x and y equals basically the same thing, you're going to. Okay. So what I want to do is look at an example of how this works as far as with values themselves. So we have a function, our f of x is x cubed minus 3x. And they want to figure out the average rate of change from x sub 1 at -2, x sub 2 at 0. They're giving you your x values. You need to figure out the f of x values, the y.
How do we know we can use like f of x for the equation and
So what we have to do to figure out what f of x is, we need to figure out what f of x is at here and f of x here.
But we don't think both, do we?
We have to.
Oh, we do.
Because we have to figure out what the value of y is at both of those spots.
But then, yeah, but then at the end,
You'll see. Okay. So what this is telling you to do then is just substitute in, direct substitution, guys. What is negative 2 cubed minus 3 times negative 2? Negative 2 cubed is 8.
Yeah. Negative.
Negative 8. Throw parentheses around it, guys. So you have negative 8 plus 6. So what do you get?
I mean,
Negative
14.
Negative 8 plus 6 is negative 2. Okay? I do the same thing with 0. What's 0 cubed?
0.
Minus 3 times 0. 0. So now you have your sets of ordered pairs.
Oh, that's easy.
The change in f of x is 0 minus negative 2
oh,
over 0 minus negative 2. What's your average rate of change? 1. What you're having to do here is you have to find the y values of the coordinates. You know what the x coordinates are, they'll be given to you. You have to substitute and figure out the y coordinates. That's the only thing that has changed from what you guys have done before as far as slopes are concerned. It's the same stuff. It's just saying that on this generic function, the slope of the secant line, the line that goes through the 2 points, has a slope of 1 for that interval. That interval might change at a different value, but for what they're going to ask you to do, that's all that is. If I do it again with between 0 and 1, I go through the same process. F of x was x cubed minus 3x. So we got our x sub 1 was at 0, our x sub 2 was at 1. Well, we knew here f of x was 0. What's 1 cubed? 1. What's 1 minus 3? Negative 2. So here, and I do the same thing. The change in f of x, negative 2 minus 0. What's that? And then 1 minus 0. What's the slope between those 2 points? Negative 2. So what's happening is, in this graph, it was increasing going from here, and then all of a sudden it's decreasing going this way. That's all it's showing. That's what this is allowing you to be able to notice. That's all it is. Okay? That's all this is. That's what these slopes do for us on these functions for the function notation. Let me get you guys the homework sheet that I have. I did add a couple of questions on day 1 stuff with some more of the finding zeros. Bless you. No, I have. I gotta get this problem. You might throw some over to the last row, please. Bless you.
No one likes that. Don't get fired.
I gotta run it off for you. It's just graphing. It's pretty easy. Oh, that, no. I'll worry about that later. What I had on here extra is, because I think it had you guys do the zeros of, what numbers was it? Like 15 and 18? On that sheet. Yeah, it had you guys doing 6 through 18 by 3. I want you also to do 19 through 24. It just a couple more problems with finding zeros. I want you guys to keep working on zeros. Okay? Yeah. So just add that in on day 1.
Wait, is it
Okay.
about 3?
Yes. No, it's just another 5 of them. Just adding them in. I basically wanted to do that whole chunk of finding zeros because it's something that we do so much, and I know that you guys tend to forget how to do that. So I wanted to add some more of those. Okay. That's all. So just add this into the day 1. I know I went through a ton of stuff today. We'll try and continue off this stuff tomorrow. There really isn't anything scary. If you guys have the spare ones that are, Jeff, I know there's a couple lying around. Thank you, gentlemen. All right.
Mr. Murphy, did you collect
At this point, it's just silly. We did most of it. So.